bearing is designed to have some level of radial flow, and to increase the retention, the pocket side has to reduce. And for that to happen, the float will decrease, and vice versa. We studied the float and we found that there is some scope of optimization. After modification of punch and die, we reduced the pocket size by 30 micron, but without crossing the design limit of minimum float requirement. And we checked the push out load before and after for all the 16 needles of the bearing, and there is a substantial improvement, 78%, in the average force required to remove the needle from a bearing. And the result, the CP-CPK improved. PPM from the last 4 months, average is 61 as compared to 352 earlier. Detection mechanism, it's a plain truth. It was a visual detection, prone to human error, chances of oversight. And the awareness is zeroed on manual inspection as the cause of the defect. And the root cause was there was no poka in the needle missing bearing. And our improvement idea was if we could make a bearing rotates along its axis, and a photoelectric sensor detects the missing needle, and the major task was this has to be automatically loaded, unloaded, and automatically defect sample has to be solved. Batch to single piece flow. The below process flow is the single piece flow, the same sequence of operation as above, but different configuration. Operations are automatic, operations are linked, and no input-output collection in the bin, and even the manpower you see above 6 reduced to 1. This is our, before we play the actual video of our work, the concept of the line. Qualifying all tests, 5 cases, qualifying all tests, Lilian indexing, and then moving to the packing. Then rotation not free, chain, drops, then missing needle, similar, and then the ID retention, and similarly for the OD retention. So if you see that the end to end, it's a linear material flow. And let's see how we check the needle missing case. Defective sample will drop down, and when all the needles are intact, it will be unloaded in a B block and moves to the next operation. And the free rotation check. This is the most fundamental and important characteristic of a bearing, that its rolling element should rotate freely. And it is the single most deciding factor for performance and life of the engine. You see the top bearing rotating fast and below is rotating slow. And how we detect it? We are, through a rack and pinion mechanism, we apply a constant torque and we check the angular displacement in a unit time. Let's say how we do it, how we were doing earlier. Manual judgment, lot of skill required. It was a subjective inspection. And now, slow rotating bearing falls down, and OK bearing drops on this chute and then to the oiling station. And retention. This is also very important from the point of view of handling of the bearing, whether it is our end or at the customer end or even in the transit moment. So needle should remain intact before it gets fitted into the vehicle. So this, if the needle, we apply a 3 kg load, and if on all the needles in the bearing, if the needle drops, get detected in the needle missing operation station and sorted out. This is the video of the entire our line, the 2 retention checking, then the coming to the needle miss checking, and then to the rotational check. In fact, the Mahindra SQA team have visited and acknowledged this development. So if the result, the process risk, you see the detection. Now it is visual to automatic control. It is the components, the defective components are automatically locked and doesn't prevents from further processing. The substantial improvement in the reduction of the process risk potential. The benefits are compiled. The PPM reduced to 17%, no complaint from the last 6 months. Productivity increased by 3-fold, and WM inventory is 0 now, since it is a single piece flow. And the most important, the intangibles. Now it is subjective to objective inspection. Means human error scope is completely eliminated. These are the relevant documents, standardized, training imparted, the visual, the work instruction displayed on the machine. In conclusion, I would say, with a profound knowledge and working with the opinion of the the population and seeking for the end-to-end solution made our process robust and its measurement robust and yielded many proactive solutions. Hence, economical product and reliable process. Thank you.